So I always make sure that I go over the various versions of the product and the quotient rules before I actually begin to do a problem. And so in lecture, we should have seen, hey, I have this kind of a problem where I have to recognize that I have two functions that are being multiplied together. And then again, when I go over this in class, I will give you sort of a preview that if you have g of x and it's the second thing in the function, it's the left product, or sorry, the right product, you will need to take the derivative of that eventually. And then for the left side of the product, I will need to identify that, and then I will also need to take the derivative of it. Okay, and the same thing is going on over here. So this is very, very similar. Do you see the notation here? And if you take a look, where was that beautiful blue? If you take a look at this, but I don't do so good with S's. They look like 5s, so I'm not going to write that version. All right. In fact, I usually use U's and V's, and you'll see me do that in class over and over again. Okay. And so when I'm differentiating without a calculator, that means to take the derivative. And so I'm going to say this is my first piece, right? So I have this 3x squared minus a 2. Now, because I'm sticking to the book right now, I'm going to say that this is f of x. I know that's f of x. That's a different f of x. So if it makes you uncomfortable, you can use your own notation that we already went over in class. And here, the derivative of that would be 3x squared minus 2. The derivative of that is going to be a 6x. Now, when I take the derivative over here of this piece, and I'm going to call this g of x, you could call it something different, or actually a lot of kids leave it off altogether. They just sort of write 4 things, right? The 2 pieces on top, and then their derivatives going down. The derivative of 2x plus 3 is just a 2. So I will definitely see kids who just write something like this on the AP exam, and that's allowed because there's no middle point, there's no points given for the setup. There's no points given for the setup. So what's points are awarded for is stating that if you have a derivative that is named f of x, when you find its derivative, you should put f prime of x. And then what else points are given for is actually having that derivative be correct. So that's actually the most important part. So I think of it as multiplying these two things, 3x squared minus 2 times that 2. And then, ready, these two things being multiplied. And so this is a, you know what, you could do it like this. You could put the 6x in front so that it looks like something that I'm planning to distribute, because I definitely am planning to distribute here. And you see, it doesn't matter what order you write them down in. If you were given a free response question, that would be your answer. But it's more likely that your question is going to actually be a multiple choice. So we'll need to go ahead and distribute in order to be able to identify our answer. So 2 times 3x squared is 6x squared. 2 times the negative 2 is a negative 4. 6x times a 2x is a 12x squared, and 6x times 3 is a 18x. So I'm looking at it now and I'm saying definitely there are some terms that can be combined. So 6x squared plus 12x squared is 18x squared. I'm going to put this into standard form by listing each term in descending order of degree, and that should be my derivative. Now, we have another method here. We could have just FOILed these out, right? So we could have just done some first outside, insides, and lasts and gotten the answer to what f of x is, and then just taken the derivative of that. But I like to show that in class. I'm not going to do that in this video. For part 2, I'm looking at it and I'm saying, well, that doesn't look like multiplication problem to me. That, to me, looks like a division problem. Now, in class, I'll show you that this is actually, we can do it as a multiplication problem. We can use the product rule, but we're not going to do that in this video. We're just going to use this version of the quotient rule. And what I'll mention is, do you remember how I had like an f of x and then I had an f prime of x? Well, I'm still going to have that. Isn't that interesting? And then I have, for this next one, a g of x and a g prime of x. That is also interesting. But these terms are not interchangeable, and here's why. G of x is your denominator for the quotient that you're taking, and that's very important that you know that G of x gets squared and stays in the denominator, and it also has to be the first term. So where I could interchange, if I wanted to, I could interchange this one and that one and just write them, in opposite order. And that would be okay, because eventually when I do my my distribution and putting stuff into standard form, I'll sort everything out. But when you're doing the quotient rule, this must be here. The placement matters with this one. This one up here, placement does not matter. But on the quotient rule, it does. So when we do the quotient rule, I'm going to make sure that that denominator, which again, I'll show you in the second version of it, that denominator, he calls it b. It should be b squared in the bottom. Isn't that cute? And then b should be the first thing, okay? So now I'm going to actually do this quotient rule problem, but I needed more space, so I'm going to move it like that. So I'm going to say that my derivative will look like this. It will have a 2 minus a 3x, and it will have it in the bottom squared, okay? Also, it will be present in the top without taking a derivative. Okay, and then there'll be a minus sign, and then yes, you should definitely take the derivative now. So the derivative of 2 minus 3x, and if you are using your notation here, you say this is g of x, well that would be 2 minus 3x. Here I would say that g prime of x would end up being the derivative of 2 is 0, and the derivative of negative 3x is a negative 3. And so right here, I will put that negative 3. But I'm not going to distribute or work out any problem of the problem yet, because I want to come back to the top. The top, I'm going to say that was f of x. So f of x was 2x squared minus 4x plus 3. And it should go as a multiplier to the derivative of g of x. There's still like a cross multiplying thing going on, and I want to show it to you. Oops, I said it out loud. I was going to make this video without saying it out loud, but in my mind, I always think of this as a cross multiplying. So this one right here, I say, oh, well, this times this and this times that. Well, it feels like cross multiplying to me. It's not cross multiplying, but it feels like it. So I always think of it as being like that. And that's how come I know that right here, this is where my 2x squared plus 4x plus 3, it goes there, okay? And then what's the derivative of that? The derivative of that will be 2x squared. The derivative would be 4x. The derivative of negative 4x is a negative 4. So right here, I have the original function, and it should be multiplied by a derivative. So this is my derivative, 4x minus 3. And again, placement mattered. So I paid attention to where I put things when I did this particular version. And I'm looking at the top and I'm thinking to myself, okay, I can definitely see there's going to be some terms that I can combine. On the bottom, do not expand. Please promise me. Do not expand. It is possible to factor out a negative here, and by the way, the negative would come out, the negative would be squared, and I would be able to simplify that, but it might not matter, okay? It might not be important, but I guarantee you will not need to actually expand it, okay? So by the way, I'm missing that prime mark. I meant to write it, and I may have even said it. Sometimes when I'm doing little tick marks on my screen, it doesn't register. So be very careful with your pencil, okay? Make sure that you get that prime mark on it to say that was the derivative. And then I do want to actually distribute some stuff and simplify it out. It's just that in the interests of time, I'm going to leave that to you, okay? And so for problem number 3, when I'm looking at it, remember how I said that we could turn it into a multiplication problem? We definitely could. We could also do it as a derivative using the quotient rule. So I have two methods, and I just don't even know which one I like better. You know what I mean? Except I think ultimately that this is, let me think about this problem just a little bit. If I say this is -9/5 and that I'm multiplying that by 1 over x squared, does it pop into your head that the negative power, that x squared could be a -2, in which case I could literally just use the product rule. So I want to, like I desperately want to, because I think to myself, well, -9/5, that's just the derivative. That's just a constant. It goes out in front. When I'm trying to imagine the derivative, though, I want to know what power it is that I'm going to use. If I'm using the power rule, I'm going to use a power of -2. So I'm going to say, hey, this should be multiplied by -2, and that x has an exponent of -2, and that should go down by 1. So when I end up with my final answer here, I will say that -9 times -2 is 18. This is 18 over 5. And hey, this becomes a -3. And if I want to, I can actually drop it into the denominator and make it positive just like that. Boom, I found that answer. So it's like I said, you don't get any points here for showing that, except for if you stop there. If you decided to stop there, you are actually allowed to call that the answer. If you were looking for multiple choices, this is where we needed to get, okay? And so we wouldn't care about the middle step at all. Some kids can actually do that work in their head as well. What if I didn't realize that? Is it possible that the quotient rule would work? Indeed it would, but it's a lot messier. Okay, so when you can see that, division by that x squared there is really a negative exponent rule, it's a lot sweeter. All right, so for number 4 then, e to the x and sine of x, those two functions, you can't distribute those, you know what I mean? You have to calculate what e to the power, whatever power it is you want it to be, then you have to calculate whatever you want sine to be, and then you would have to multiply those things together. So this is not a polynomial. So we're not doing polynomial operations. In this case, it is very clearly going to be a product rule problem. I have one thing times the other thing. You just needed to realize that you had those two functions. So this function right here, I'm going to take the derivative of it, and hey, what do I get when I take the derivative of it? It's the same thing. So I'm going to call this f of x because I'm using the notation of the book, and I'm going to stick to that first version. The other version I can't do s's, so it is what it is. All right, so the derivative of e to the x is e to the x, and then this other function, I'm going to call it g of x, and I know it's not the same as this g of x. It's just a placeholder to remind me that I think of these two products and I take the two derivatives. The derivative of sine, by the way, is cosine. And if you decide to leave off the f of x, the f prime of x, the g of x, the g prime of x, that is okay. You are allowed to leave that off because there's no points awarded for showing your work. You can skip directly to, ready, g prime of x is what? Well, don't forget there's an e, a 3, okay? Haha, right? Oh, I forgot. There was a 3. Don't forget the constant. I don't bring it down with me because constants just bother me. I always put that guy out in front, but then I have this thing built into my soul that says, hey, did you look for your constant, the one that you like to forget about? And at the end of a problem, sometimes I'll be like, I'll make that equal sign just a little bit smaller just so I can fit that 3 in there. And I didn't originally write it down. Oh, I can fit it in there. But you make sure that if you're like me and you want to be lazy like that, that you always check at the end, did I remember my constant? Okay? And you'll get better at it too. Trust me. It's taken me years to get that ingrained. All right, so then I say that I have e to the x and I have an e to the x, and here it really doesn't matter what order I do it in. I could put the cosine here, I could put the sine here, or vice versa. And by the way, am I done? Sure, I am definitely done. I like it a little bit better if, and I will mention this, you see how I have this 3 out in front? And do you see how there's an e to the x and another e to the x? I like this better if, ready, what I do is I say that this is a 3e to the x. Should I have done that in purple? I should have done that in purple. But you'll forgive me. 3e to the x, and that I am gathering up like terms and saying I have a cosine x plus a sine x, actually. And again, for no particular reason, I just like the way it looks when I say sine of x plus cosine of x, probably because of that identity. I want to get it to as close to that identity and go, yep, that definitely is not the identity that I was looking for, so I don't have any more substitutions. I should go look for my answer. Now, on the AP exam, I can't even really tell you, would you see this answer or would you see the other answer? You're like, you mean this one? No, you probably wouldn't see that, but you might see this. Ready? 3e to x, sine of x, and again, for no particular reason, I put sine first. 3e to the x cosine of x. That might be your answer, okay? Another possible answer, which I said it doesn't matter which order I put it in. Sorry, that it does matter that it looks like an exponent, though. Come on, that x needs to be an exponent. E to the x cosine of x plus 3e to the x sine of x. There's a lot of different right answers, which is why multiple choices can be difficult, okay? So any one of these could be your answer, all right? There you go. Get to work on your homework.